So I want to welcome all of you to Hacks Hackers New York City. We are very, very excited to be here. Once again, your last chance to log on to the Wi-Fi. Got that? Yes? Okay. So I just want to let you know a little bit about who we are. For those of you who've never been to Hacks Hackers before, there are three organizers. There's me. You'll know me better as Mac Diva. There is Al Shah from ProPublica, who unfortunately couldn't make it here tonight. And we also have Jeremy Singer-Vine. Jeremy, say hello. He's in the back. You should talk to him, too. We have many, many people to thank for this evening, especially the New School and Heather Chaplin, Professor Heather Chaplin at the back. Thank you so much for making this happen for us. For those of you who are curious about what you ate for dinner, this evening we had our food come to us from Xi'an Famous Foods, many, many locations throughout New York City. Go there and ask for the liang pi noodles. And if you say it with that accent, it'll be really, really good. And finally, I would like to thank Sean Connolly, right here, our lovely Sean Connolly. Sean, where are you? Sean may still be outside checking people in. He is that dedicated. All right, so you've had a chance to say hello to the people next to you. People at the very back, stay saying forward. People at the front, turn backward and say hello to the people you haven't met yet, just for a few minutes. All right, so for those of you who've never been to a Hacks Hackers event before, we bring journalists, designers, and developers together at the intersection of what we do to advance journalism, basically to try and make it more awesome. One of the really, really awesome things about being in this community is that we do a lot of making and a lot of learning. We are doing what we call our NYCAR preview this evening. For those of you who've never been to NYCAR before, it is the annual, basically like a hands-on conference/workshop for people who specialize in investigative journalism. And we are very, very lucky tonight to be talking about, or giving you a little preview of solving common problems in investigative journalism. Or as Dan Wynn, where are you, Dan? Dan Wynn? Dan, I saw you momentarily. There you are. As Dan pointed out, it's solving common data problems in investigative journalism. So, such as, all right, this is the wonderful NYCAR logo from a few years ago. You can still buy the T-shirt at ire.org. So the data problems like Regex, featuring Amanda Hickman, who you will meet shortly. Things like census microdata, which we'll get a look at from Rob Gebeloff shortly. And finally, we're going to get a preview, an alpha preview of FOIA Machine. Very exciting. So, to get started, please welcome Amanda Hickman, doing Regex on a napkin. I hope you all have your little pieces of paper.
I feel like I should just sort of like give up because the XKCD is better than anything I've got for you. And I can tell that you can't quite hear me. So this is going to be a little bit of an adventure. I am a lecturer at the CUNY Graduate School of Journalism where I teach data analysis, data visualization, sometimes just plain old reporting, and sometimes games. And I'm also going to be doing a really awesome panel at NYCAR about designing data journalism classes. And I'm going to be doing a regular expressions class that's not going to be 20 minutes long. It's going to be 60 minutes in a computer lab with computers that are all preloaded with the same sets of data. So if this gives you a headache and you're coming to NYCAR, you should totally come to the session because it will be awesome and you will have your temples massaged by getting to actually try this stuff out. So it's going to be a little experimental since we are not sitting in workstations. I will also say that I spent about 20 minutes researching printing this on actual napkins before I remembered that my primary goal was to figure out how to teach regular expressions without a computer lab. So if you want a sort of ersatz napkin, I have some and there's a bunch floating around. So how many of you guys signed up for the wireless and got a wireless password sent to you? Did anybody notice something that was incredibly irritating about the sign-up process? What was most irritating? That's ridiculous, right? If you don't have your phone number in the right format, it doesn't work. It would be great if there was a way that computers could take phone numbers that were written in any format and make them into the format the system needs. And there is, and it's called regular expressions. And the first thing you'll learn when you start studying regular expressions is that they're actually quite irregular, and every programming language has these little variations in the flavor, but most of what's on the cards I handed out will work in almost any regular expression syntax. And what regular expressions are is a mechanism, a regular search, a regular language system for describing patterns that you can see with your eyes and you want to tell the computer what the pattern is. And we're going to walk through, this is going to be a little experimental, and if you have your computer, that'll be fun for you. If you don't, you should get a napkin because you could try scribbling this stuff out. So I like to start with, this is doing a little quirky thing. I like to start, when I do regular expressions with students, I like to start with something that's a block of text that you could probably think of 10 or 12 different ways to get it into a spreadsheet. And in this case, it's a block of text that has some errors introduced to make this more fun for us. And I don't know if you guys are familiar with Jordan Q. Zimmerman. He's a really important player on the Nationals. And it's a block of text that we probably don't actually have any particular need for. But this is player data from the Washington Nationals 2012 lineup that I stole from Anthony DeBarros, who uses it to demonstrate some cool Excel functions for getting something like this turned into something like this, which you can open in a spreadsheet. And if you don't know how you would open that in a spreadsheet, you should come see me and we can talk about other workshops that you should go to at NYCAR. But you can still come to regular expressions. So I want to sort of think about, if I want to go from here to here, what's the first easy, obvious, this is a softball, what's the first easy, obvious thing that I would want to sort of put into a search string to start to kind of whittle down getting names, positions, and ages out of this? Name. And then you need your napkin to know what's going to come after that. But then we can start to get into the super fun of regular expressions, which is, name is the same in all of these, right? But then we have all these words that are different. And so what we want is to start with, what does a W give us? You guys have napkins. Does anybody need a napkin still? So the W gives us what again? Any word character. And what is, we have to be good to the live streaming. What does the asterisk give us? Any number of them. So it can be the word name followed by no letters. It could be the word name followed by one letter. It could be the word name followed by 25 letters. And I'm going to do something else that's really fun that will enforce for you that you should be following Hacks Hackers NYC on Twitter so that you can see the URLs for our little regular expressions. So what I want to start to walk through with everybody is a really nice tool, even if you're really good at regular expressions, for figuring out something like a really long, complicated regular expression. There's a website called Rubular, and what it does is takes your input string and your regular expression and shows you what it's finding. So I went ahead and I gave us a word and a space and another word, so a bunch of letters, a space, and another bunch of letters. But there's a couple people who are missing in this particular grab. Who did we leave out? People with middle initials. Do you guys actually know the Nationals? This is like a baseball crowd. So you know that his name's not Jordan Q. Zimmerman. Mr. Smith is also a really important one. So we've got people with middle initials. Who else is sort of falling out of this particular catch-all? Double-barreled surnames. So now we all have to look down at our napkins and scribble on our napkins and say to ourselves, what could we do to also capture those random things in the middle? And I'm going to show you. So now we've added a bracket, which gives us any of the characters inside the bracket. And because we put an asterisk, it's 0 or more of any of those characters. And the characters that we need to be able to capture are the hyphen, the spaces, because we know there's going to be some of those, and the periods in those middle names. And that still didn't get it because we're still missing something, which is that there might actually be a middle initial as well. So now it's doing something that's a little greedy, and it's capturing also their position, but we're not going to deal with greed yet. So now we've got all the names. And I'm going to show you the next thing, which is really nice, which is the replace string, which lets us say that what we want, we don't want to capture that name colon, but we do want to get those names. So we're going to put some brackets around it, some parentheses around it. And then we get into my other favorite thing about Rubular, which is that it shows you exactly what it's finding for each row. So I'm going to sort of power through the next piece. So the next thing we have is the position, and we see that it starts with that POS. And as soon as we add it to our search string, it gets broken out and doesn't get collected with the names anymore. But the positions are all these 2-letter acronyms. So we could specify them with that A to Z, so one capital letter and another capital letter. Does anybody have any ideas from looking at your clever little napkin about other ways that we could say that we want 2 letters? A /W and then a 2 in curly brackets would work. So would A to Z and then a 2 in curly brackets. But this is the next super fun thing, which is going to come in really handy when we get to the phone numbers, which is that we can say we want exactly 2 instances of whatever it's finding with those curly brackets. And so I'm going to sort of plow us ahead and show you the full actual search expression. And then we're going to try one more challenge together, and then I'm going to pass the baton on to someone else. But does anybody have sort of questions about why you would use a regular expression at this point? That's good. That's what I want. I want to hear from people about the last time. I know that there's a bunch of people here who use regular expressions all the time in your newsrooms. And I want to hear about the last time you used a regular expression. And I'm going to start with Martin, because I know he's told me regular expression stories recently. Have you? Maybe you haven't. Michael has told me regular expression stories recently.
Finding until a certain character and not including that character. You want like an actual narrative?
Yeah.
Taking OCR texts and we had to take OCR text and then pull out certain patterns in it. I can't actually remember what the patterns were, but there were a bunch of weird characters we wanted to get rid of and some weird delimiters.
Were you possibly looking for dates that prisoners entered and exited Guantanamo Bay? Maybe. All right. So, is this not working for me? Somebody else laughed when I said that. Who else laughed when I said that? Because I know you have a regular expression story. In the pink shirt. I can see you smirking. Did you not have a regular expression? Yes, you, who's like turning around. All right. If you're wearing a pink shirt and you have a regular expression story, Macdiva's bringing you the mic. I don't know.
Do you have a regular expression story, Paul?
Oh, I'm going to tell a story. I think the most relevant story here was last month I went to the Data Liberation Hackathon, and we had a bunch of reports from Amnesty International. We were trying to find, we were trying to pull information about torture out of the reports, and they were big 300-page reports. And so we used regular expressions to find the section that would look like that started with the name of the country, so we knew there was a new country, and then and it would say something like head of state, or head of government, or head of state and government. So we used a regular expression to find that sentence, and that's how we knew we were at a new country.
So, is anybody else actually burning to tell their story about regular expressions in the newsroom? No. So I tweeted out 2 more links, one of which is slightly broken. Oh no, I fixed it. So we can kind of tear through this. We can get that 2-character position. We can get the age, which I did as 2 digits. I could also have done /D and then a 2 and curly braces. We can get their weight, which I did as 3 digits. I wasn't very fussy about getting when they were born or where they were born. And then I introduced a really fun thing in the salary, which I'm going to walk through when we hop over to, I just tweeted out 2 URLs. And the second one is for Regex 101, which is new to me, but kind of cool in what it does for you in understanding irregular expressions. So Regex 101 will actually take your regular expression, break it down into its component parts, and tell you what each of them means and why it's capturing what it captures, which is really handy when you're trying to sort of take something apart or figure out how something works. And I think you can see this, but one of the characters that I use, one of the things that comes up in this data set is that some people have salaries that are listed as numbers, and some people have salaries that are not. So can you guys see what Christian Garcia's salary is on this particular? NA. So searching for, what I initially did was I searched for numbers. I'm going back to Rebuilder because it's, I can tell you guys are squinting. Regex 101 is hard to look at. So I said it might be 1 or more digits. That would be the /D followed by a plus. Or, and that's that bar, or it's the letter N, a slash, and the letter A. But we use slashes all over the place to convey meaningful things in regular expressions. We have to escape the slash with a backslash. So anybody have questions at this point? Yeah.
So you use after born, like you were saying, very simple to grab that data. Is there a reason not to use that for things like position and other, because of how structured the data is?
For things like, can you rephrase your question?
Born, you've just got period asterisk, right? To pull any characters between born and the next subheader. Why wouldn't you use that after position or age or anything like that?
You could. So, remind me of your name? Chris. What Chris is pointing out is that I did a super lazy thing to get the city of birth for these folks. which is that I took our word born, colon, and then I said dot. And what does the dot mean? Any character whatsoever. And then I put an asterisk, and the asterisk tells us what? As many as there are. And so that just keeps going until it gets to the next word in the search string. Sometimes that's all you need. I could have used that for all of these, but then we wouldn't have got to look at how you can use digits and the to and curly braces and other really wildly thrilling and exciting things. So yeah, the dot was laziness. And the other thing that's kind of nice is, as it turns out, this is breaking them into, we still just see, what is it? Lexington, comma, Kentucky. If I actually then take this into a text editor, and I don't have a text editor set up on Chris's computer, so I'm not going to sort of pop over and show you how you would do this search and then replace. We'll go back to. But I can. It's going to end up giving me, if I set this up with search and replace with a comma between each of these fields, it's going to end up separating the city and states anyway. So other questions about this lovely 2012 Washington Nationals lineup? Chris, what's my time check? Yeah. I think we're going to, I want to sort of walk you through another, I'm not going to do it like make everybody respond, but this is actually like a list of phone numbers that somebody posted to the internet claiming that they are home phone numbers of the Church of Scientology leadership. I have no idea whether that's true or not. But they're in all kinds of crazy different formats, which is probably representative of how most of you entered your phone numbers in the Wi-Fi form the first time you did it. Wait. I didn't keep the URL for the completed version of it, but we are going to do a quick on the back of your napkin, because we just walked through all of this. How would we find, we need to break this into 3 parts to format it into a regular phone number, right? So the first thing we want is what? We want the area code, right? Yeah, so we want the area code, and that's 3 letters. And then we want something, maybe it's a hyphen, maybe it's a parens. And then we want another number that's also 3 letters, 3 numbers long. And we just start to build it out. And I'm not going to make us walk all the way through it, because I thought I had saved the version of Regex 101 where we had this all working. But you can see, I mean, we can all see with our own eyes that these are all phone numbers, and they're all made up of some random characters, maybe no characters at all, for an area code, the exchange, and then the end of the phone number. So we can use a regular expression to turn those right around. So I'm going to stop there. We are going to spend a full hour walking through this from the beginning. So if you actually want to get your hands dirty and play with actually using regular expressions, it'll be really fun.
So do you know what day and time your session is at NYCAR?
No idea.
Okay, NYCAR schedule. We'll figure that out. Yes, but thank you very much, Amanda. It's okay to clap. All right. So how many of you have worked with the census data at all? Yes, yes. You know how tricky and complicated and sometimes like head-smashingly difficult it can be, right? We are very, very fortunate to have Rob Gebeloff from the New York Times with us, giving us his sort of 20-minute preview of microdata from the US Census. And Rob can tell us more about what exactly that is. I forgot to look up when Rob's session is. but do you know offhand?
Yeah, we're going to be doing a panel at Thursday at 2, and then we are going to be doing a hands-on. So you could, we're going to go through an exercise of doing your own queries Friday at 2.
All right, so Thursday or Friday. Yes, Malik? Oh, right, and Amanda's session Saturday at 2. Thank you. All right, Rob, you ready?
Yes.
All right, let's go.
Okay, so I am often called upon at different NYCAR functions to talk about census data because I have the fortune and misfortune to have been doing it for a very long time. My first newspaper job, I was in Saginaw, Michigan, circa 1991-92, and you know, they said you're going to be covering General Motors, higher education, and the census. You know, because there was like 6 people on the staff. And the way we covered the census in 1991 was they sent somebody from our chain to training on how to read data off 9-track tapes. And that guy faxed me a list of all the tables in the 1990 census. And I read it like it was a menu, and I faxed him back the tables I wanted. And then he faxed me back the data. And I sat, because being 21 years old, 22 years old in Saginaw, Michigan, there was nothing else to do. I spent like 3 weeks typing the stuff in to a copy of Excel I found on a Mac in the photo lab. And then I spent another couple of weeks analyzing it, and finally I had my big meeting with the editor, and he said, well, what do you think we could do about the census? And I proposed this 5-part series on how Saginaw, Michigan had changed in the 1980s. And he said, I want something longer. How many tracks are there in Saginaw? And I said, well, I think there's about 55, 56. I got it. We'll do a year-long series, and you'll write a story about every tract, 1 a week. So that was my introduction to the census. But moving on. Most of the time we talk about census data, that we're familiar with, we're talking about a hierarchical set of tables organized by either a topic or by geography. You got a bunch of tables about families or about race, or a bunch of tables about New Jersey. And it looks something like this. Come on. Boom. Well, that didn't work, but it looks like this. It's a, a table of, and we call this published data, and you could use this in a story, and programming-wise, there's APIs now. There's different ways you can get it for whatever geography you want, and you could write queries and get this. So there's only there's kind of a problem with this though, which is that what if you are, even though there's thousands of tables, there's some limits to it, and one of the limits is, you're limited to basically whatever they decide to publish, what variables they publish, what parameters they publish. Every census table, like for example, the marriage table, the universe is people, adults over 16 years of age. What if you want to look at more specific age groups? So that's one limitation. Another one is, I'm sure if you're new to the census, you've encountered, great, I found something good. How do I find it in previous years? That could be a challenge. And the other thing is, if you have like a great idea, it's a lot of work to assemble the data from all these tables to prove or disprove your thesis. So all these things, microdata could help. Microdata is an actual database of the responses to the census. They anonymize it so you don't violate the privacy of the person who filled out the form. But essentially, when you get the data, each record is a row, each column is a variable. So you can, get counts of every person has a long row, and there's some information that is household level, just about the household, and then about the specific person in the household. And the sample size is about 1% of the population, so you're talking about 3+ million records for a census year in this database. And So it's a great resource, and once you have that, you can write any query you want. If you want to look at the marriage rate of people who are between 19 and 22, or the marriage rate of anything in the non-published table, you could write your own query because you're going to have the marital status and the specific age of the people in the sample. And I'm not going to click on another URL for now, but it's essentially, remember when they were introducing me, that thing they had before? It's not an easy data set to work with. It's a long string. Everything is encoded, 00111197, and you have to essentially write your own lookup tables to say what each of the codes means, and so that could be a real pain in the butt. However, there's an organization called IPUMS at the University of Minnesota at the Population Center, and I will pop out here to show you that. IPUMS is sort of, they've got grants to be a repository of this data, and they do a lot of value added to it. And that's what I'm going to go through, a quick example of what you can do using IPUMS and the value added they provide. And I'm just going to go into this mode now because it's easier. Yeah, so they provide the data in multiple formats. So you could either use an online query tool and do most of what you want to do very quickly, or you can download the data. And the great thing is when you download the data, it gives you labels attached. So for example, when you get the state FIPS code, it gives you the labels, so you could look at it either as New Jersey equals 34 or simply in text in New Jersey. They do a lot of work to standardize the data across the years, so you don't have to worry about is that table from the 1990 census compatible with the table from the 2010 census. They have a lot of tools to make sure that you're on track with that, and they also provide bonus calculated fields that aren't included in the census, and I'll get to that at the end. But the thing that is really great and that I use all the time is before you go to all the trouble of assembling a data set to analyze, to download, and clean up, they have this online query tool. Now that's my Uncle Franco. Why do I bring up Uncle Franco? Well, one of the first PUMS ideas I had once I learned about this was I noticed like in New Jersey, there seems to be every town has 3 or 4 old man barbershops. And a lot of times you go in there and there's a lot of Italian guys. And you know, this is my Uncle Franco. He gave me my first haircut. Well, I guess he's not an issue anymore, but he's a friend of our family, and he told the story about essentially it was an economic thing. You're an immigrant coming to this country. It's a skill you could pick up without needing language skills, so a lot of Italian men who came in that era were barbers. So what can published census tables tell us about this trend I imagined about the tradition of Italian barbers in New Jersey? I mean, the census tables will tell you how many people were born in Italy. The census tables can tell you how many are barbers. That, I'll grant you, is in the census tables. However, oh God, that's horrible grammar. What these census tables cannot tell you, though, is the crosstab of that. How many barbers were born in Italy, or how the Italian barber population has changed over time. So that's where you would go to something like census microdata if you want to answer this pressing question of the day. And usually when I work with the microdata, and this is like a feature I've been bugging them to change all the time, I keep 2 browser windows open. One is the actual query interface, and this is kind of the data dictionary where it lists all the variables and has information about it. So let me quickly walk you through how we would address this problem of I want to know how many Italian-born barbers there are in New Jersey. You know, like any kind of computer, I tell this when I'm teaching SQL or any kind of query thing, the first thing you want to do when you're about to do a project is you want to visualize what your results like and design a query to match that. So we are going to pick, they have different samples, by the way. It goes back to 1850 if you're doing historical research. But they have one sample that's all in one, the 1850 to 2012 sample. That's what we're working in. And the way this is set up, you could either, you know, search for your variables down here on the left in this menu. They're all listed here. Or you can use the data dictionary. So in this case, you know, what I want to do is I'm envisioning a query where the columns are the year and the place of birth is the row. And then I'm going to put a filter on saying, just give me barbers. So the way you would do that is you would look up, you know, as it turns out, the variable for year is called year. But let's say I didn't know what the variable for place of birth is. I would go over to this handy code book, and under person records, there's something called race, ethnicity, and nativity. And if you open that up, it lists all the variables, and here's one, birthplace. And this will tell you which census year that variable is available. And then you could drill into it, and it will tell you more important things to make sure you are using the variable properly. Here's a definition of what it is. It tells you information about how comparable the variable is over years. It tells you what the universe is. Remember I said before, like certain things like the employment status is only for people who are 16 and over. Or the marital status, I always get these mixed up, is for people over a certain 15 and over. And then it gives you a code sheet. And it tells you the numeric codes and the country codes. And it tells you what years the census included that in the census form. Very, very handy stuff. So, just saving time, I pre-wrote the query. So we did that for BPL. And, you know, so this is now getting to the value added. The one thing that's really annoying if you ever do any economic reporting and try and use census data, they change occupation codes like every 6 years. And it's a real pain in the neck if you want to like track different industries over time or different occupations over time. In this data set, however, the IPMS people do some standardization, and they have two sets of codes where they take whatever the current year's code is and morph it into a standard set of codes. One is called OCC 1990, and because I'm really going back a long ways, and since the occupation barber has probably not changed much, I feel pretty safe in saying that it's been consistent over time, the actual task of being a barber. I'm going to use something called OCC 1950. This melds every occupation code up into modern time into what the 1950 equivalent would be, and that is good for giving us a time series. The other thing I'm going to do is, you know, as you know, the census changed from a decennial census to now the ACS comes out every year. Just for simplicity's sake, I'm going to limit it to the decennial, you know, 50, 60, 70, 80, 90 through 2010. You notice I use Firefox for this, by the way, mainly because Firefox has a plugin I love called Table to Clipboard, which makes it very easy to get tabular results into an Excel spreadsheet. So there's my filter. In my options here, I'm going to take the column percentage, which is going to tell me the share of the total that goes to each country. Very, very important thing here. They will calculate the confidence interval. Because remember, we're working with sample data, and with a sample, there's a margin of error around your results. This will, and it's a pain in the neck to calculate it on your own. This will do it for you. Don't necessarily need color coding. All right, so I'll give this a run. So these live queries are always the most exciting queries. You're wondering, is it going to work? Is the server at the University of Minnesota going to crap out on me? Oh, there we go. So we get our results, and as promised, it documents what your query is up here. Good thing to save when you're doing a bunch of these and you save them. And it gives you our, and notice here, it's when it's place of birth, a state is a place of birth, so it gives you the U.S. states. But I'm going to just go back to my PowerPoint to zoom in more closely on what we learned about Italy. This is if you want to play at home. So the great thing about this is, so it gave me an estimate of, the first line is the percent of all barbers that were born in Italy. And if you notice, you go back to 1950, in the United States, the estimate is 6% of all barbers were born in Italy, and you go up to modern times, it's half of 1%. And then it also tells you the numeric estimate, and this is the number that were born in Italy and of all barbers. But here's the great thing, it gives you the confidence interval, and this is whenever you're working with sample data, this is not a hard, fast rule, but it's a good guidepost to tell you, well, how good does the census feel about this estimate? And in this case, with a sample size this big, our results are pretty reasonable. But at the time I was learning this, I was working at a newspaper in New Jersey. And and of course, I wanted to really just focus in on, what was going on in New Jersey. So, and I also wanted to just focus in on, because I observed through doing several queries that most of these Italian barbers were men. So I said, okay, what if I reran this query and this time added state equals New Jersey, gender equals male. That's state 34, sex equals 1. Sometimes you know these in your sleep after a while. So I could just add that here. And let me run this again. And while that's running, I will cheat and go ahead to the results. So you notice now we're really into something interesting. Just among people who live in New Jersey, in 1950, around when my Uncle Franco arrived in this country, a full third of the people who said they were barbers were born in Italy. And over time, this number has just fallen off the wayside to the barbers by 2010, who are still working today, only about 4% of it. But the other thing I wanted to show you with this is notice what happened when our sample size now of all people who are barbers in New Jersey, we're not in the hundreds of thousands, we're just in the thousands. And so look what happened to our confidence interval. For this estimate of 33.7%, what this is saying, we're 95% sure it's between 25 and 44%. That is large. And I wanted to leave you with this closing thought. When you work with microdata, because this is what you have to think about all the time, is what's good and what's not. I mean, everyone asks that question. When I do this type of work, how do I know my answer's right? And the great thing about this is that there's actually no right answer. There's probably lots of wrong answers. And anyone you talk to about this, they say it's really a judgment call. And it's in that way, it's a lot like journalism. It's like, who do you interview for a story? How do you know your story's fair? Well, it's because you're trained as a journalist to know who to interview and to interview people correctly. The other factors you would consider are, is the trend line you're getting, if we go back to the slide, is it consistent or bumpy? Usually, if this thing is going up and down and up and down, there could be something funky with the data unless you have reason to believe that that's what really happened. The last resort you have also is going to do your regular reporting. What does your regular reporting tell you about what the data is showing? And that, again, applies to computer-assisted reporting across the board. Obviously that is not the most serious example I could give you, but I just thought as a starter to give you an idea of what you could do with this. Some of the more recent stories I've done, we did a piece more recently about the new healthcare law, the Obamacare, and the reporter came up with the question of, well, some states, the Supreme Court allowed some states to opt out of it. And so the question was, what would be the impact in the states where people opted out? What would be the impact in the states where that opted in? And this is for people below the poverty line. And what you discover when you do a story like this is like there's a whole data regime for healthcare and poverty. There's actually a healthcare poverty rate. There's healthcare households, because if you think about it, when you think about the health insurance in a household, there could be 3 different situations within one household. Let's say you have grandparents living with their grown children, and the grandparents have their own health plan, but the grown children have their own health plan, and their kids have their own health plan. So you have to use the microdata to sort of divide the households into health insurance units. And then once you do that, you have to calculate income differently and poverty differently. Well, some researchers who do that work did that part of it for other researchers, and they gave it to IPUMS. So when I went to IPUMS, I was able to download special health insurance variables that don't come with the regular data set, and that allowed me to quickly identify the health insurance status and poverty status of people in a way that is consistent with what other researchers are doing. And probably the most famous one The only reason my stories ever get famous, by the way, is because there's a great app with it. I don't know why that is. I don't know if these links are going to work, but no, let me just go for it. Look at this. Google knows what I'm going for. This was a piece where it started out with this idea of, can we profile the characteristics of the 1%? But the thing that we got the most attention for is, this idea of what is the 1%? If you make $100,000 in one place, is your economic status different than if you make $100,000 in another place? And what we did is we used this microdata to calculate 100 income percentiles for every metro area in the country. And I turned this over to, who was it who did this? Is the name on it? Jeremy White. And he wrote this little app that said just that. If you make $75,000, I handed him a text file that had all the income percentiles for all these different places, and it shows you, relatively speaking, if you make $75,000, you're in different spots in different places. But the bottom line is, anything that you see in the census, any variable you see, you can customize and cross it with any other variable. And using the IPMS tools makes it easy to do and make sure, sometimes I'll use that IPMS tool to do my initial query, and then I'll download the IPMS full data set, and I happen to use SPSS, but you could do it in R, you could do it in Stata, and then you could do your own queries and write scripts and do whatever else fun stuff you guys all like to do. And I'll hang around and answer questions later if you want.
All right, so we have, yes, we have the FOIA machine team next. Wait, before we do that, and as they're getting set up, Rob, when are your sessions?
Thursday and Friday at 2.
Thursday and Friday at 2. Make a note of it. Ah, okay. So if you want the hands-on piece, Friday at 2 o'clock. The last group that is going to be speaking with us is going to be giving us an alpha version of this. I heard there were some rumblings about like code kind of working, maybe kind of, sort of, I don't know. And as you know, with all conferences and presentations, the most exciting and the most daring part of all of this is live code. So I think that may be what we're looking at, yeah?
Well, right now we're just looking at the presentation, but yeah, we'll do a live demo after after the presentation's over, and hopefully that'll work.
Okay. So this is Shane Shifflett, Coulter Jones, and Steve Melendez. You ready?
Sure.
All right.
All right, so I'm Coulter Jones. I work at WNYC. I'm a data reporter. Before that, I worked at a place called the Center for Investigative Reporting out in California. We did a lot of long-form investigative data journalism type work, and what came up more often than not was having to request documents and data from various states and countries, and how many people have had to file we call them FOILs in New York, we call them OPRAs in New Jersey, Sunshine Requests in Missouri, FOIA for the federal government, any public records request, right? So we all know that doing that, it's a lot of different rules, a lot of different people you have to talk to, everything varies. So, FOIA machine was our solution to this, which, as that says so wonderfully, is an open source platform. We're trying to empower people to be better about how they file a request and be able to find the right contact and be able to track those requests, because one of the things that I did, because I'm not a terribly organized person, is I'd send out 20 requests, and in New York, they're supposed to respond in 5 days. In California, they're supposed to respond in 10. In some states, there is no requirement at all on how soon they have to respond. And like a month would go by, and my editor would be like, "Oh, how are those requests going?" I go, "Oh, shit. They never got back to me." And I didn't have a good reminding system. I didn't have anything else. Shane and I both used to work at the Center for Investigative Reporting. It started as an idea out of a hackathon day that we did together. Eventually, we started building it. We needed more support. We had a Kickstarter. Thank you if any of you donated to it. Investigative reporters and editors have given some support to it. We got matching funds from RJI and Knight. And that's kind of where we're at. We're in development. We're somewhere between an alpha and a beta on the project. Where's the cursor? All right, I guess we'll just do that. So where we're at now, Shane and Steve are our primary developers on it. We're about through 2 of the 3 phases. We've sent out 900 invitations. We have about 200 activated users. I'm using it right now to track my open records request. You know, journalists at Huffington Post, CIR, WNYC are all using it. We're on time and we're under budget, but I'm here before Shane talks and shows you the code in our most recent deployment. I'm here to talk about failure. So here are the 5 problems we face in building our robot friend. The first one is existing systems and workflow. And this is just that sometimes you will ask to send a request and they won't have an email address associated with it, which is pretty simple. I have sent requests to lots of places where they've said they only accept it by letter or fax. Our system is built kind of along an email system because we thought that's pretty standard and most places should have that. But there's still a lot of government bureaucracy that we're dealing with as we try and make this thing work. The second big failure we've had is laws, and this shouldn't be one, but since like the raison d'etre of this is to help people deal with all the various laws that we deal with in requesting documents. But nonetheless, we have 51 different laws just in the US. People have asked for support in other countries. If I want to send a request to the EU, we have the capability of dealing with that. But every state creates a different problem. In Georgia, they specifically mention ASCII. It's as a delimited text file type that you can request for if they have the capability. And Georgia is supposed to respond to your request within 3 days. In New York, it's 5 days. Again, if the government has the capability, they are supposed to export data for you. In the state of Missouri, they have a totally different set of rules for shape files, which are the geographic files that people deal with. And that's a whole nother issue, but they can charge you like $20,000 for those. So every state has all these various kinds of rules. I grew up in Omaha, Nebraska. In Omaha, Nebraska, there's a specific exemption for archaeological sites. So if I want to know where the archaeological sites in my state are, they can tell me it's none of my business. So this, you know, every state is sort of built the same way. There's a response time period on how long they have to respond. There are certain exemptions. There's how much they can charge. But even within that broad parameter, we have this problem we've dealt with of how specific should we be as we help people file requests. So we actually just killed a feature that we had built on the exemption on the data request that I think Shane killed 2 hours ago.
Yeah.
So yeah, we're still trying to solve this problem of like what's the best way to make it as broad as possible to help people, but not be too specific to your problem. Let's be honest, we've had technology problems. This is just as simple as we're using Mailgun and a email wrapper. What's great when Shane shows you the system is that as you send a request, if they respond to your original request, it all gets sucked in and you kind of have this log of everything that's going on. Never fucking happens. Nobody ever responds to the email as they're supposed to. They forward it to like a subordinate who forwards it to somebody else, and then it comes in. Half the time ends up in my WNYC Postini spam filter, and so these are just like issues that we're having to deal with that we could have guessed, but you know, in practice we're dealing with more problems. You know, is it really ready? I have never really built software before. By background, I was a journalist, you know, generic reporter. I learned data skills along the way, but we had all these people who were interested. They wanted to get in. They wanted to give us feedback. And I remember talking to Shane, like, I don't know if we should be adding users yet. He's like, well, we need to get some live feedback, not just from us. And I had this vision that like we'd send out invites and our servers would like crash. Like everyone was just chomping at the bit to send a fucking request from us, and they didn't know how to do it. Before, like their editor was like, oh, where's your story? And it's like, well, I was gonna send a request, but FOIA machine's not done yet, so sorry. And of course, that's not what happened. We sent out, 100 requests a day for a while, and we're getting 1 or 2 people to activate their accounts. They look at it and give us a little bit of feedback, but they won't actually use it. So this is, this sort of internal debate of like, we know certain features aren't working, what's not working. And the fifth and final thing is finding good robot photos for our presentations. And this is sort of which I actually did spend too much time last night, and my wife was not happy about, Googling robot photos for this. But, this is just everything that we didn't anticipate. There was a question at one point, like, well, if you're building this email server, how are you going to prevent spammers? We have that built in, but there's all these questions that come up on how you're doing it, and like, so I've sent my requests, and you're really asking people to sort of change the way they do this. If you're a user who sends a lot of open records requests, you probably have your own system. My system used to be a Google Doc, and I would just like check it every day on like what the status was. So, there's just a lot of stuff we haven't anticipated. Shane is going to do the more important part of kind of show where you are in the code. But before that, if you haven't signed up, send us an email at info@foiamachine.org or go to foiamachine.org. Follow us on Twitter. I'm Coulter, Steve, and Shane. We'd love more users. We'd love your feedback. And if you want to, contribute code or, just test out the features, we'd love to talk to you more about it. So.
Cool. So I get to do the honors and show you guys what we've been working on for the last couple months. Let me switch over here real quick. So kind of what you're looking at right here is our dashboard of requests, and this is just going to sort of highlight where all the requests you've sent out sort of stand. Have they been fulfilled? Do you still need to send some of them? What is the date that they're due by? So as you kind of fill out a request, it's going to you're going to associate a contact with it. Every contact in our database has an agency which goes back to the law, the statute, and so we know when the request will be due by, and we kind of calculate that stuff. And so here you can get a quick sort of like flyby view of where everything stands at. And for somebody like me, I have enough requests going on. This is kind of a subset of everything that's in my email inbox. But there's a couple nice features also that we can put right here, which is to show sort of, we have links directly to the laws. So maybe as you get responses back from different FOIA officers, I can't see that all the way. As you get responses back from different FOIA officers, and maybe they're denying you for certain aspects of the law, you can go and cite, what are exactly the fees that they're allowed to charge you for, what does the law actually say, and where can they draw those lines for the exemptions or for denying you that request. And kind of as we've been designing this and sorry, what's that?
We also, on the dashboard.
Right here?
Yeah, well, when you go back to the law, the different contacts that we have. So one thing that Shane didn't mention is, so we don't have a ton of requests in it right now, but we have 2 contacts associated with the Pennsylvania right to know law. We know it takes 5 days for them to initially respond to us, and there are 4 requests out. As this builds up, this dashboard will exist more. So if you're filing a request for the first time in Pennsylvania, you'll know how many active live contacts there are that people have sent requests to.
Yeah,
so.
And for actual emails where the contact has responded to the email sent out by FOIA machine, we'll be able to kind of aggregate the average response time for all of these contacts. So like, you can almost do a comparison between agencies among states, which doesn't really exist at this point. So that'll be a really cool feature once we have more people using it. But sort of as you can see, like, when you go to create a request, we have 2 sort of options for that. We have sort of like a very Gmail-like feature where you can go and start typing in your subject and the content of your request if you know exactly what you're looking for. And you can go ahead and search for an agency. And sorry, let me type it in correctly. So if you know who you're looking for, you can type it in. If it's already in our database, then you can select it. You can add any contacts from there. If you created the contact, or if you have sort of special privileges, you can edit that contact, add some notes to it that will maybe help some other people further down the line if they've responded about certain issues, or maybe they're better at getting back to you than other contacts have been. We'll sort of reveal that in form of notes that you can tag contact with, or you can go back and you can add your own specific agency if you want, and associate it with the government, and it'll automatically pick up all the data that's associated with those laws. But maybe you're not so comfortable with actually filling out a request or typing up the text of it, and we've also developed a sort of like guided process that will allow you to fill in a couple variables, maybe just, give it an email subject line or something, set the privacy level. You can share any of these requests with other users on FOIA Machine. You can generate a link that you can share around with people, maybe in your newsroom, if they want to see it. Or you can keep it private to yourself or share it publicly, which will show up on a sort of a list view page on the FOIA Machine site. And you can go ahead and select your contacts, select your agency, all that stuff. If you have a date range you're looking for, sort of if you want to describe your request, I'll just put in some test text here. And then as we get to the close of this form, you have some options that you can configure that will sort of decide which variable boilerplate text to drop in. And at the end of the day, you'll have something here that you can fire off to the public information officer, and hopefully within a few days you'd receive your response. And so then you go back to the request dashboard, and you check on that periodically. Maybe you don't want to check FOIA Machine site every day, so it's going to send out emails when a request becomes overdue. If somebody hasn't responded to that email, you haven't checked in recently, you're going to get an email in 20 days saying, hey, what's the status of this request? Would you like to come back and try and follow up with the point of contact to make sure you get your data or whatever information you're requesting. So this is sort of where we're at right now. We're kind of in the middle of a big UI redesign. Coulter mentioned that we had gone through 2 of the 3 phases, and we'd been talking about inviting people, and so this is kind of an interesting project because it's Kickstarter, and we want to make sure people, get to provide feedback to us. So we're slowly sending out invites, and people have been doing that, but they are working with like alpha, beta level software yet. There's been some bugs, we fixed a lot of those up. And now we're mostly to the point where it's like, is this software usable for somebody who hasn't stared at it for 3 or 4 months? And so we're going through and remedying a lot of that stuff that we've kind of left alone so we get the basic infrastructure working. So if you go to FOIA Machine and you haven't already signed up for it, if you put in your email address, you can randomly be selected, or just come up and talk to us and we can send you an invite tonight. And you can play around with it and also have a chance to say something.
Show of hands, has anybody signed up? Has anybody actually been given an account already? No, all right, well, we'll fix that. If you have, what you might notice is this is not the dashboard that we currently have live. It's a lot clunkier and it's not necessarily intuitive. Not that this is perfect either, but it's pretty hard to see sort of the status of. One other thing that we didn't mention is, so as journalists, a lot of times we might have an editor, we might have someone we're working with on a project. Any request you create, you can then add users to a group and then share that with the group. And then so if you're working with another reporter, so I'm a data reporter, a lot of times I might work with somebody who's a specific beat knowledge area. You can create a group or just share specifically with somebody. So in sending that initial request, I can let that reporter see all the status updates as we get more information. So this is the request that went out. In theory, as I said, that case that doesn't seem to happen as much as we had envisioned or dreamed, if they responded to, we would have all the emails and everything responded to in this big body of text. We're working on a note feature, and by we, I mean Shane and Steve are working very hard, and I talk about we working on it, because that's the kind of guy I am. But that will allow you to add notes when you get a request that says, oh, they responded and said they need 20 more days, or, oh, they responded and said that they want a clarification, and here's my email. So, yeah, we're building it. We're building it in an open source way in which that we have stats and everything that is spit out, even though you can keep anything private. If you've used Document Cloud, it's a similar sort of philosophy of like nothing that you do has to go public, but the general larger metadata can help sort of feed, and the context you create can help share information. So I don't know how we doing on time, or does anybody have any questions specifically on how it works? I think, yeah, he has a microphone. Sure.
Hey, any plans to integrate with like Muckrock? And kind of what they're doing is a little bit more manual, but I think it might hiccup over some of the speed bumps that you're encountering.
So, no, although we have been talking to Muckrock, they're two very similar projects that sort of diverge in various areas. There's a lot of overlap. Mike Morsey, who's behind that, really great guy and has done a lot of awesome work, and they send some great requests. We are sort of, I always get in trouble when I talk about it, like trying to describe the difference, and I don't know if I have a great way to put it, but we're trying to build more of a software platform as opposed to any sort of specific service would be the biggest difference that I would say. I should mention we're not totally advertising this, but if you do want to pull the code down and mess with it, if you talk to us at another time, we are allowing people to do that. We've let one data journalist that we know who was interested in it. So we're trying to just open source the code. Some newsrooms don't want to use a platform that's a website. So that's sort of, I guess, the biggest philosophy. But we have talked to them. We've talked about possibly doing things like creating open API standards for how we're releasing it. So, I mean, what I would love to see is us, FOIA, which is the Reporters Committee for Freedom of Information, or Freedom of the Press, has their own system. If we could all sort of have, like, come together and push sort of better standards from governments on releasing information, that's kind of where we're at.
Just for the, yeah, or you could
go ahead, and then you have to answer, Shane.
Sure. Someone else? Oh, well, just from what you were saying about the privacy, is it sort of the expectation in order to make it work as a community platform that reporters would make their requests visible to everyone else after their stories come out? Like you wouldn't want necessarily to see what you're working on?
Right. Yeah, totally. So that's been one of the concerns that we've heard a lot about as we talk to reporters and newsrooms and stuff. You know, and there's two sides to it, because you can also like FOIA the FOIA, and you can know what other reporters are working on, basically. I mean, they have the FOIAonline.gov site, and you can go and search the New York Times and see everything the New York Times is working on right now for the couple of agencies that they support. But I mean, yeah, basically, you don't want to divulge the story like unnecessarily if you don't have to. So, you know, we've kept that in mind. I don't want anything that I'm working on out there before it's published. So,
except right now, but.
Yeah,
But yeah, so we've talked about after your request has either been denied or approved. I think we have a several month, eventually mandatory release of that information.
It's a sunset clause, right? And so after, I think we have it set at 6 months right now. And so in 6 months, you leave your request private, it's been fulfilled, we'll send out emails to you, and we'll basically say, if you don't react to this message, we're going to automatically publish this request in 5 days. And what we do think that will help is, like, it will help people learn how to write better requests, and also see what's out there. We'll have an open database of stuff that people can kind of search by and see, like, okay, well, somebody's already filed this request, maybe it's out of date, and it needs to be refreshed. I can just take the text and plop in the 2 variables, you know, for the year or whatever, and send it along its way, and in a couple of weeks we'll have something, you know. So I think there is that potential for it, but it depends if people share. Yeah. Yeah, and then all you have to do is just respond to it, and we'll never ask you again, basically. So, yeah. Any other questions?
All good? Okay. Thank you very much.
Thank you.
So thank you again to Shane Shifflett and Coulter Jones and Steve Melendez, who's just like there in spirit.
Steve can ask.
Okay.
He can answer any questions you have.
Right. So yes, that's right. So Steve actually is a really, really amazing developer and journalist who's now freelancing after having kind of released himself from WNYC. So let's see here. Okay. So a couple more things for you before we get into the rest of the social part of the evening. Wait for it. Wait for it. Okay. So here we go. If you want to go and see the full-on sessions during NYCAR, Amanda's Regex hands-on is on Saturday at 2 o'clock. Rob's Census Microdata Hands-On is Friday at 2 o'clock, and FOIA Machine Demo is Thursday at 10 o'clock in the morning, and now that I look at this, I probably should have flipped the order, sorry. Keep that in mind. And then the last thing is NYCAR. NYCAR is really, really intense. It is 4 days of going and learning. There are panels, there are workshops, there's demos. There's people just like cramming tons and tons and tons of information into your head. So much so, and not only that, but there's a lot of sessions that are up against each other. And so you always ask yourself, like, what should I have gone to? And oh my God, I'm like, you know, that I've got that FOMO thing going on, right? So I, for the last 3 years, have been collecting every single tutorial, reference, a bunch of the lightning talks, a lot of the tools. You will find it here on the NYCAR collection at our lovely Jump or Bitly link. And I'm collecting that again this year. So if you haven't seen it before, it's a really, you will be astounded when you go to the site. So it is almost every single thing that every single presenter will be talking about or showing you. And it will give you the time that you need to spend to learn all of the amazing things that are going to be shared with you next week. So that said, thank you very much for joining us. We've got this room for until about 9:30, so feel free to hang out. There are still other things to drink here and maybe other things to eat. Yes, so feel free to ask questions. Rob is still here, Amanda's here, and the FOIA Machine team are here, so feel free to talk to them, talk to me. I haven't gotten a chance to meet every one of you yet, so I'm going to be running around saying hello. Thank you very much, and good night, live stream. All right.